Hello students, in this video we will learn about the combination of resistors. For practical purposes, the combination of resistors is required. So what is the practical purpose? Okay, we have to understand first this word, practical purpose. So this is the conductor and this conductor is connected to the battery. This is positive terminal, this is negative terminal of the battery. When potential difference V is applied across the ends, the current will be flowing through the conductor along this direction. Let the resistance of this direction of this conductor is 2 ohm. But in this electrical circuit, we need 10 ohm of resistance. Okay, and we do not have any single conductor of 10 ohm of resistance. So how will we find the 10 ohm of resistance? Okay, by combination. And if the resistance of this conductor is 2 ohm and we need the 1 ohm of resistance in this electrical circuit, so how will we find? By the combination. Okay, so the combination is of two types, the series combination and the parallel combination. So in this video, first we will learn about the series combination. So what is the series combination? Let this is the conductor or this is the conductor. Listen here. Conductor has some resistance. So conductor is also called the resistor. Conductor is also called the resistor. So let this is the resistor and another resistor is this, and another resistor is this. These are three resistors. So what is the series combination? In the series combination, two or more resistors are connected and connected end to end. End to end means the second end of the previous resistor is connected to the first end of next resistor and so on. Okay, or we can see here, let this is the first resistor of resistance R1 and this is the second resistor of resistance R2 and this is the third resistor of resistance R3. So this is the second end and this is the first end of first resistor. So the second end of the first resistor is connected to the first end of second resistor, and second end of the second resistor is connected to the first end of the third resistor. Okay, here we are considering about the three resistors of resistance R1, R2 and R3, and the second end of this last resistor is connected to the negative terminal of the battery, and the first end of first resistor is connected to the positive terminal of the battery. Okay, let this is positive terminal, this is negative terminal. Okay, this is the junction and this is also the junction. Let we have to find the total resistance of this combination. Let this is point A and this is point B. So we have to find the total resistance between point A and B. This total resistance is also called the equivalent resistance of the combination. So we have to find now the equivalent resistance of the series combination. Okay, so this is the first point of this resistor and this is second point of this resistance. So between 2 points, this point and this point, the potential difference between the two ends of the first resistor is, let this is V1, and the potential difference between two ends of the second resistor is, let this is V2, and the potential difference between two ends of the third resistor is V3. Okay, now in the series combination, if potential difference V is applied, the current will be flowing along this direction, and the current will same for each registers. Current will be same for each registers. You have to remember here, in the series combination, current is flowing through the each register is same. Okay, and the potential difference is different for different registers, because this if we are going along this direction, then potential drops, potential decreases with the distance. That's why the potential difference across the two terminals, across the two ends of each registers is decreased. Okay, you know, and the potential, let the potential difference between A and B is V. So clearly the total potential difference between A and B will be the sum of the potential difference of resistor first, potential difference between two ends of the second resistor, and the potential difference between 2 points of the third resistor. So V will be equal V1 plus V2 plus V3. Here potential difference is distributed, but current is same for each registers. So which value or which quantity is distributed, we have to find that quantity. So here potential difference is distributed for each registers. That's why we have to find the total potential difference between the 2 points A and B. Okay, by Ohm's law, here we know that the Ohm's law is V equal R into I. Okay, for the first resistor, here potential difference will be 1, and the resistance of this resistor is R1, but the current is same for each resistor. That's why currents here only I, or this is the value. And for the second resistor, here potential difference V2 will be R2 into I, and the potential difference between two ends of the third resistor is V3 equal R3 into I. Okay, this is the first equation. So on putting the value in the first equation, here we will get V equal the value of V1 R1 into I, and the value of V2 R2 into I, and value of V3 R3 into I. Okay, listen here, or I, we can take common I, then R1 plus R2 plus R3, and is equal to V. But by Ohm's law, V will be equal R into I, where R is the equivalent resistance between 2 points. That's why here RS will be there. RS means the equivalent resistance in series. The first letter series. In this word, here as series, S is there. That's why here S for series for S symbol. Okay, now that's why in this equation, from this equation we have to put the value. So RS I equal I R1 R2 R3. I cancel. So RS will be equal R1 plus R2 plus R3. This is the equivalent resistance in series combination. Okay, here conclusion is that thus the equivalent resistance of the series combination is equal to the sum of the resistance of the individual resistors. This is the definition. Okay, now in this series combination there are laws of series combination. Okay, so here the first law, the total and the potential difference between the potential difference of the combination is equal to the sum of the potential difference of each resistors. Okay, let this is, and here second is that the total or equivalent resistance of the combination is equal to the sum of the resistances of individual resistors. Okay, this is, and in this series, in this combination, you know, resistance of first, resistance of second, resistance of third, this is the equivalent resistance. So the resistance of these are, let the resistance of this is 1 ohm, resistance of this is R2 equal 2 ohm, this is R3 equal 3 ohm, and what will be there, 1 plus 2 plus 3 on putting the value, so RS will be 6. Okay, so here the 6 is the greater than that of individual resistance of resistors. This is the third law. What is the equivalent resistance of the combination is greater than the greatest resistance of this combination, and the combination, yes, this is the third law. Okay, these are the laws of combination of series, the series combination. Okay, so now second is the parallel combination. So we will understand this parallel combination of resistors. So you can take the pic, you can take the screenshot. Okay, now we start the next combination, parallel combination of the resistors. In the parallel combination, the first end of each resistors is connected by the one common point, and the second ends of each resistor is connected to another single common point in the parallel combination. So look here, let this is the resistor of resistance R1, and this is the resistance of resistor of resistance R2, and this is the resistor of resistance R3. Okay, before this, in the series combination of 3 resistors, the equivalent resistance, we derived the formula RS equal R1 plus R2 plus R3. Okay, if here n resistors are connected in the series, then what will be the equivalent resistance? So here equivalent resistance RS will be R1 plus R2 plus R3 plus up to Rn. So this will be the formula or the expression for the equivalent resistance of the series combination. Okay, now we are looking here the parallel combination of resistors. Let this point A is the common point, and the first end of the first resistor is connected to this common point, first end of second resistor is also connected to the first point, common point, and third resistor, and the first end of third resistor is also connected to the point A. That's why this is first common point. Let this is the second common point B. This is the second end of first resistor. So connect with the common point B, and this is also connected to the common point B, and this second end of the third resistor is also connected to the second common point B. Okay, this is the parallel combination of resistors. So what is the parallel combination of resistors? If two or more resistors are combined such that the first end of each resistor is connected to the one common point and the second end of each resistor is connected to the another common point B, then this combination is called the parallel combination. Okay, and between the two common point here battery is connected like this. Okay, in the parallel combination here a potential difference V is applied across the two points A and B. Here current is flowing I, but at point A here current is divided into three ways: first way, second way, and this is third way. Let the part of the current flowing through the first resistor is I1, and the current part of the current flowing through the second resistor is I2, and current flowing through the third resistor is I3. So here I will be equal to I1 plus I2 plus I3, but the potential difference, these are connected to this point, and the second ends of each resistor is connected to B. So the potential difference, because these are connected in same point, first ends are connected to same point and second ends are connected to another same point. That's why the potential difference across the two ends of each resistor will be same. But here current is divided into three parts. So which value or which quantity is divided here? Current is divided here. So we have to find the total current. Okay. Now by the Ohm's law, what is Ohm's law? According to the Ohm's law, V equal R into I. Okay. We have to find the value of I1, I2, I3, and we have to put the value of I1, I2, I3. So from this equation, here the current for first, current is equal I equal V upon R. Current flowing through the first conductor will be I1 will be equal V upon R1, because R1 resistance of resistors are different, but potential difference between 2 points of each resistor is same. That's why here V. And current flowing through the second resistor will be I2 equal V upon R2, and the current flowing through the resistor R3 will be I3 equal V upon R3. Okay. On putting the value of values in this equation, then I will be equal value of I1 equal V upon R1 plus I2 V upon R2 plus I3 V upon R3. Okay, this V is common for each step. So here each term. So here we have to take common. So V common and R1 remaining part R2 plus R3. It is equal to V. Okay. But V from Ohm's law, V equal V. This is not V. This is I. So I from Ohm's law, I equal V upon R. V upon R. But this R is the equivalent resistance in the parallel combination. Okay. So that's why here Rp will be there. P is the first letter of parallel word. On putting the value of I in this equation, V upon Rp is equal V into 1 upon R1 plus 1 upon R2 plus 1 upon R3. V cancel by V, and here 1 upon Rp will be equal 1 upon R1 plus 1 upon R2 plus 1 upon R3. This is the equivalent, this is the formula of parallel combination. Okay, and Rp is the equivalent resistance of parallel combination. Okay, if here n resistors are connected in parallel, that's why the equation will be 1 upon Rp equal 1 upon R1 plus 1 upon R2 plus 1 upon R3 plus up to 1 upon Rn. This expression will be for the equivalent resistance in the parallel combination. Okay, so here definition is that the reciprocal of the equivalent resistance in the parallel combination is equal to the reciprocal of the sum of the reciprocal of individual individual resistance. Okay, this is the parallel combination. Okay, understood? Okay, thanks.